So we continue our work with section 7.2 today, the ambiguous case of the law of sines. When we did the law of sines in the earlier section, it was either angle side angle or angle angle side, guaranteeing that we get one triangle. Today we want to talk about SSA. Now, there's no congruence theorem for SSA, but there is ways that you can show triangles. So, descriptions of the ambiguous case, the possible number of outcomes when you apply the law of sines. If angle A is acute, you get 0 triangles. If applying the law of sines leads you to the fact that the sine of B is greater than 1, remember, the range of sine is anything between -1 and 1 inclusive, so you can't be over 1. It means A is less than H, which is less than B. You get one triangle, if when you apply the law of sines, you get the sine of B equaling 1, which means that A equals H, and H is greater than B. You could also get one acute triangle if when you apply the law of sines, you get the sine of B is less than 1, and A must be greater than or equal to B. You could get two acute triangles if 0 is less than the sine of B sub 1, less than 1, H is less than A, which is less than B, and when you take the angle A that you're given plus B2, it's less than 180 degrees. If the given angle is obtuse, you get 0 triangles. Once again, if the sine of B is greater than or equal to 1, and side A is less than or equal to side B, and you get an obtuse, if A is obtuse, you get one triangle. If 0 is less than the sine of B, less than 1, and A is greater than B. So those are the possible cases when you're doing SSA. When you apply the law of sines, remember for any angle theta of triangle, 0 is less than sine of theta, which is less than or equal to 1. If the sine of theta equals 1, then theta is 90, and the triangle is a right triangle. The sine of theta has to equal the sine of 180 minus theta. Supplementary angles have the same value. Remember, if we think about the unit circle, the sine is positive in quadrant 1, and it's positive in quadrant 2. So when we do this SSA, that's where we get the possibilities at. The smallest angle is opposite the shortest side, the largest angle is opposite the longest side, the middle valued angle is opposite the intermediate side, assuming that the triangle has sides of different lengths. So that's when you're done, make sure that your triangle makes sense. Let's take a look at our first example. Solving the ambiguous case, triangle ABC with B equaling 55 degrees, 40 minutes, side B equaling 8.94 meters, and side A equaling 25.1 meters. It's crucial when you do these to draw a diagram and make sure that it's sketched and labeled properly. So here's a triangle ABC. We'll call this angle B, making this 55 degrees, 40 minutes. I'm going to finish my triangle here. That makes this side be 8.94 meters, and if this is angle A, 25.1 meters, and thus this would be angle C. So when we set up our law of sines, getting the unknown on the top, we get the sine of B is to B as the sine of A is to A. Well, B is our 55 degrees, 40 minutes. Side B is 8.94 meters. Sine A is what we don't know, and angle A is what we don't know. Side A is 25.1. So as we cross multiply this, 8.94 times the sine of A equaling 25.1 times the sine of 55 degrees, 40 minutes. Make sure your calculators are in radian mode or degree mode because you're working in triangles now. So 25.1. Let me pull up my Desmos here. Again, notice I'm in degrees, so 25.1 times the sine, 55 plus 40 divided by 60. I'm just going to go ahead and let my calculator do that conversion. And then we'll divide that by 8.94. And we get to the sine of b, 2.318. The sine of a, excuse me, is 2.318. Well, remember that the sine of a has to be somewhere between 0 and 1, with 1 being inclusive. This goes beyond that. Therefore, you have no such triangle. Let me make that such look a little nicer here. Let's take a look at example 2. Example 2, you can see since they give us the directions that we're going to get 2 triangles, we'll go ahead and get 2 triangles. So again, we're going to make a sketch. So angle A is 55.3 degrees, which means that this is side A, which has to be 22.8 feet. And we'll make this be side B, thus making this angle B and this angle C. Remember, the side is the lowercase letter of the opposite angle, which is a capital letter. So angle A, side A. Angle B, side B. Angle C, side C. So setting up the law of sines, we'll try to find angle B first, which means that the sine of B over B is equal to the sine of A over A. It's just simply a proportion. So the sine of B is to 24.9, as the sine of 55.3 is to 22.8. Now, as we do this as well, we know for a fact that since 22.8 is less than 24.9, B is going to have to be something greater than 55.3. So we'll cross multiply. 22.8 times the sine of B equals 24.9 times the sine of 55.3. Again, we're just cross multiplying, setting those cross products equal to each other like we've been doing for a while. And then we'll go ahead and divide by 22.8. And it tells us that the sine of B equals, as we go to our calculator, and we can do this all in once. So when I do it, I like to put everything on top. So 24.9 times the sine of 55.3 divided by 22.8. And just to make sure that I got my numbers in the right order, I do. We get that the sine of B is 0.8978, or 0.8979 technically. Now, that falls within the range. Therefore, we can do the inverse sine of that 0.8979. And we'll get B, back to the Desmos. So I need the inverse sine, and I just want my last answer. So I'm going to go ahead and let my calculator carry on my decimal places, and I get that B is 63.9 degrees. Now, here's where the 2 triangles come in at. This is in quadrant 1. If we find out what, we can do this and see what B could also be if it could possibly be in quadrant 2, because the sine's positive in both quadrants 1 and 2. So taking 180 minus the 63.9, our other possibility for B could be 116.1. Now, here's what you have to check. Okay? We'll call this B1 and B2. So what we need to check, we know for sure that that's 55.3 for A, so we have to check would these two angles allow us enough room to get a third angle in? So 55.3 plus 116.1, that's 171.4, which is less than 180. So two triangles are possible. And then we're going to go ahead and solve for those other two triangles. So triangle 1, which I'll put over here. So we figured out that angle B is 63.9, which means angle C will be 180 minus the sum of 55.3 plus 63.9. So I'm going to go ahead and do this on my TI, just so I can keep this up. Plus 63.9. Angle C could be 60.8 degrees. Now we need to find side C, so we'll do a law of sines on this. I'm going to go and put in my 60.8. So once again, try to use the given information. That means that it's A over the sine of A equals C over the sine of C. Again, instead of flipping back and forth, I'm just going to go ahead and let the calculator do my work here. Sine is 60.8. And then we'll divide that by the sine of 55.3. And thus C is approximately 24.2. So again, step back, make sure that your triangle makes sense. Is the shortest side opposite the smallest angle? Well, the shortest side is 22.8. It's opposite 55.3, which is the smallest angle. Yes. Is the middle-sized side opposite the middle-sized angle? Yes. 24.2 is next, opposite 60.8. And then here, 63.9. Now, on our other triangle, and I'll change colors here, and I'll make this red. Well, we got that 171.4, so I'm going to take 180 minus 171.4. This triangle C is going to be 8.6 degrees. Angle B is going to be the obtuse angle from quadrant 2, excuse me. That's 8.6 degrees, or 116.1 degrees. And then side C, once again, we'll do the same setup, 22.8 over the sine of 55.3. Again, you could use the B numbers if you wished, but you're better off to use the given information, because if you messed up B, then you're going to mess up the other part as well. And then I'm just going to cross multiply and divide these. So it's 22.8 times the sine of 8.6 divided by the sine of 55.3. And thus side C is approximately 4.1. So C is the smallest angle, opposite the shortest side. A is the opposite, 22.8, opposite 55.3, and then B. Makes sense. Plus, we can also check for the fact of if we add 4.1 to 22.8, that gets us 26.9, which is greater than 24.9, so that does make it a triangle. So as we do the applications, let sides A and B and angle A be given in triangle ABC. The law of sines can be used to calculate the value of sine B. If applying the law of sines results in an equation having sine of B being greater than 1, then no triangle satisfies the given conditions. If the sine of B equals 1, then one triangle satisfies the given conditions, and B is 90 degrees. If 0 is less than the sine of B, less than 1, then either 1 or 2 triangles satisfy the conditions. If the sine of B equals K, then let B sub 1 equal the inverse sine of K, and use B1 for the first triangle. We'll let B2 be 180 minus B1, And if the A that we're given plus B2 is less than 180, then a second triangle exists. In that case, we use B2 for B in the second triangle. That's the example that we just did. Okay, this is crucial. If 180 minus B1, if A plus that proposed second angle is less than 180, then we can make it. If it's more than that, then we're over 180, and a triangles always add up to 180. So as we take a look at example 3, so given that A is 43.5 degrees, A is 10.7, and C is 7.2. So again, I'm going to make my sketch. So I'm going to call this angle A, which makes this 43.5 degrees, which makes this 10.7. And we'll make this be 7.2, which makes this angle C, this angle B, and this side B. Well, as we go to work with this, we're going to find angle C first because that's got the side that we know. And we can see that side C is less than side A, so we know that angle C has to be less than 43.5 degrees. So we'll go ahead and do our law of sines, which is C over the sine of C equaling A over the sine of A in this case. So 7.2 over the sine of C equals 10.7 over the sine of 43.5, which means cross multiplying gets us 10.7 times the sine of C equals 7.2 times the sine of 43.5. I'm going to go ahead and go to my calculator, and I'm just going to use my TI at this point, times the sine of 43.5, and I'm going to divide that by 10.7. And I get that the sine of C is approximately 0.4632. Which means that if I know the sine, I need to use the inverse sine to get the angle. And again, let your calculator carry the decimal places. So I need the inverse sine of that answer. And I find out the angle C is approximately 27.6 degrees. That would be C1. Then C2 would be 180 minus that 27.6 degrees, which means that our proposed C2 would be 152.4 degrees. But we have a couple things helping us here. Number one, we already said that C has to be less than 43.5 degrees. So this 152.4 isn't possible because that's not less than 43.5. The other thing, if we went ahead and did this and did the 43.5 that we know plus that 152.4, that gives us 195.9, which is not less than or equal to 180. Therefore, the second triangle does not exist, and the only triangle is when C equals 27.6. Which means we can then find angle B, because the triangle is always 180, so that's 180 minus 43.5 plus 27.6. Again, I'm just humming this along in my calculator this morning. Therefore, angle B is going to be 108.9 degrees. And then we can do our law of sines, which is B over the sine of 108.9 equals 10.7 over the sine of 43.5. $10.7 times the sine of 108.9 divided by the sine of 43.5. And we get that B equals 14.7. So again, if I go ahead and fill in the rest of my triangle here, this is 108.9, this is 14.7. Step back, make sure that your triangle makes sense. Is the shortest side opposite the smallest angle? Yes. Middle side, middle angle? Yes. Longest side, largest angle? Yes. If I add the two short sides together, do I get something greater than the third side? 7.2 plus 10.7, 17.9. That is definitely bigger than 14.7, so thus my triangle makes sense. In example 4, sometimes we can come up with this without really having to think for a second. So if I draw this out for a real quick second, and let me draw that a little bit better. We're going to make angle A be 104 degrees. Which makes side A be 26.8. And they're saying B, well, I'll call this angle B, which makes this side B, which is 31.3. Well, remember, in a triangle, the longest side is opposite the largest angle. Well, 104 has got to be the biggest angle because it's an obtuse angle, and a triangle can only have one obtuse angle in it. So therefore, therefore side A must be the longest side. So let me write this out here. Since angle A is the greatest, therefore side A must be the longest. And since 26.8 is less than 31.3, no triangle exists under these conditions. We don't have to do the whole law of sines. We just know it can't happen. And that is your 7-2, your ambiguous case of the law of sines.